The Light from Beyond, a Cosmic Discovery. Prologue. The eternal question ****. For as long as humanity has gazed at the stars, we've wondered, are we alone? The question is echoed through campfires, observatories, and lecture halls, uniting dreamers and scientists alike. It's a question that binds us to the cosmos, a longing to know if there are others out there looking back at us. In the summer of 2025, that question took on a new urgency as the James Webb Space Telescope, JWST, turned its golden eye toward a distant world and found something extraordinary, something that might just change everything. Chapter 1. A Glimmer in the Void. Dr. Elena Marquez stood in the control room of NASA's Goddard Space Flight Center, her eyes fixed on a screen displaying data streaming from the James Webb Space Telescope. The room buzzed with quiet anticipation, the hum of computers mingling with the soft chatter of engineers and astronomers. It was June 1st, 2025, and the team had been analyzing infrared data from Proxima Centauri b, the closest known exoplanet to Earth, just 4.24 light-years away. Elena, a seasoned astronomer with a penchant for chasing cosmic mysteries, had spent years studying exoplanets, but nothing had prepared her for this moment. The JWST, humanity's most advanced observatory, was designed to peer into the universe's deepest secrets. Its 18 hexagonal mirrors, coated in gold, captured infrared light with unprecedented precision, allowing it to see through cosmic dust and darkness. For weeks, the telescope had been trained on Proxima Centauri b, a rocky world orbiting the red dwarf star Proxima Centauri. The planet was tantalizingly close in cosmic terms, yet shrouded in mystery. Was it a barren rock, scorched by its star's flares? Or could it harbor life? Elena's colleague, Dr. David Kipping, leaned over his shoulder, his brow furrowed. "This can't be right," he muttered, pointing at a spike in the data. A series of brilliant bursts of light, rhythmic and precise, emanating from the planet's dark side. The signals were unlike anything they'd seen before. They weren't the chaotic emissions of a star or the steady glow of reflected sunlight. They were structured, almost deliberate. "City lights," Elena whispered, her voice barely audible. The words felt absurd even as they left her lips, but the data was undeniable. The JWST had detected beams of light, narrow in frequency, radiating for what appeared to be an urban area on Proxima Centauri b. The implications were staggering. Could these be the lights of an alien metropolis, glowing in the eternal night of a tidally locked world? Chapter 2. The Telescope that Sees the Unseen. The James Webb Space Telescope was a marvel of human ingenuity, a $10 billion testament to our desire to explore the unknown. Launched in 2021, it had already rewritten the history of the early universe, capturing images of galaxies born just millions of years after the Big Bang. But its true power lay in its ability to study exoplanets, worlds orbiting distant stars. With its infrared sensitivity, the JWST could detect the faint heat signatures of planets, analyze their atmospheres, and even pick up the glimmers of artificial light, if such a thing existed. Proxima Centauri b was a prime target. Orbiting its star every 11.2 Earth days, the planet was tidally locked, with one side perpetually facing its star and the other cloaked in darkness. This created extreme temperature swings. The day side was a scorching inferno, while the night side was a frozen wasteland. If life existed there, it would likely thrive in the twilight zone, a narrow band where day and night met, where temperatures might be just right for liquid water. The JWST's infrared instruments were perfectly suited for this task. Unlike visible light telescopes, which struggled to see faint signals against the glare of stars, Webb could detect the thermal emissions of planet's atmosphere, even in the dead of its night. And it was here, on the dark side of Proxima Centauri b, that the telescope had found something extraordinary. The bursts of light were not random. They flickered in a pattern, confined to a narrow frequency range far different from the broad spectrum of starlight. Elena and her team ran the data through every possible natural explanation, volcanic activity, auroras, even exotic atmospheric phenomena, but none fit. The signals were too regular, too precise. They resembled the artificial illumination of Earth cities, seen from space at night. Chapter 3. The Weight of Wonder. Word of the discovery spread like wildfire through the scientific community. At Columbia University, David Kipping called an emergency meeting with his team. "This planet is unlike anything we've studied," he said, pacing the lecture hall. "It's not just rocky, it's complex. The way it interacts with Proxima Centauri, the energy it absorbs and emits, it's behaving in ways we don't fully understand." The team pored over the JWST data, their excitement tempered by caution. Science demanded skepticism, and extraordinary claims required extraordinary evidence. Could these lights be a natural phenomenon, misinterpreted by eager minds? Or were they, as Elena dared to hope, the first evidence of an alien civilization? The public, too, was captivated. Social media platforms, especially X, exploded with speculation. Posts ranged from cautious optimism, "This could be the moment we've been waiting for," to wild theories about alien megacities and interstellar empires. Artists shared renderings of glowing cities on a distant world, their spires piercing the starry sky. The hashtag Proxima Lights trended globally, and news outlets ran breathless headlines. "Has NASA found alien cities?" Elena, however, remained grounded. She knew the road to truth was long and fraught with pitfalls. "We need more data," she told her team. "The JWST can't confirm life on its own, but it can tell us about the planet's atmosphere. If we find water vapor, methane, or ozone, we'll have a stronger case." Chapter 4. The Dance of Star and Planet. Proxima Centauri b was a world of extremes. Orbiting a red dwarf star, it was bathed in intense stellar radiation, far more volatile than the sunlight Earth received. Its proximity to its star, closer than Mercury's to the Sun, meant it absorbed an enormous amount of energy, creating dramatic temperature swings between its day and night sides. If the planet had an atmosphere, these swings would be even more pronounced, with the day side potentially reaching hundreds of degrees Celsius and the night side plunging below freezing. The JWST's ability to detect infrared radiation was key to understanding these dynamics. By analyzing the planet's thermal emissions, scientists could infer its atmospheric composition. Was it a barren rock like Mars? Or did it have a thick atmosphere, capable of trapping heat and sustaining life? The telescope's observations of Proxima Centauri b's orbit, perfectly aligned with Webb's own orbit around Earth, allowed for continuous monitoring of the planet's 11.2-day cycle. Elena's team focused on the twilight zone, the region where the planet's scorching day side met its frozen night side. This was the most likely place for life, where temperatures might allow liquid water to exist. The bursts of light, however, were coming from the dark side, a region too cold for human-like life. Unless, Elena thought, the lights were artificial, generated by a civilization with technology advanced enough to thrive in such conditions. The JWST's instruments were not designed to detect free oxygen, a key biosignature, but they could identify other markers, like methane or ozone. Finding these would suggest an atmosphere capable of supporting life. Elena and her team planned a series of follow-up observations, hoping to map the planet's atmospheric chemistry in greater detail. Chapter 5. The Limits of Vision. The James Webb Space Telescope was a triumph, but it had its limitations. While it excelled at detecting water vapor, carbon dioxide, and methane, it struggled with free oxygen, a molecule strongly associated with biological processes. For a definitive answer, astronomers would need to turn to ground-based observatories, like the extremely large telescope YELT, set to begin operations in 2027. The YELT, under construction in Chile's Atacama Desert, promised to revolutionize exoplanet studies. With a mere 39 meters wide, it would collect more light than any telescope in history, allowing for unprecedented detail in atmospheric analysis. Unlike the JWST, which orbited Earth, the YELT would peer through the planet's atmosphere, correcting for distortions with advanced adaptive optics. Elena dreamed of the day the YELT would turn its gaze on Proxima Centauri b. "Webb is giving us a glimpse," she told David, "but the YELT will let us read the fine print." For now, though, the JWST was their best tool, and its data was rewriting the rules of exoplanet science. Chapter 6. The Next Frontier. As the scientific community grappled with the implications of the discovery, Engineers and astronomers were already looking to the future. The JWST had proven that humanity could detect the faint signals of distant worlds, but new technologies were needed to take the next step. The challenge was starlight. Stars were billions of times brighter than their planets, drowning out the faint light reflected by worlds like Proxima Centauri b. To overcome this, scientists were developing innovative tools. The coronagraph, a device inside a telescope that blocks starlight while letting planetary light through, was one solution. By carefully shaping light waves, coronagraphs could dim a star's glare, revealing the planets hidden in its shadow. Another idea was a star-shade, a massive flower-shaped spacecraft that would fly thousands of kilometers ahead of the telescope, casting a shadow to block starlight. These technologies require precision on an almost unimaginable scale. A star shade would need to align with its telescope to within fractions of a millimeter across vast distances, all while surviving the harsh conditions of space. Yet the potential rewards were immense. By isolating a planet's light, scientists could analyze its atmosphere for biosignatures, chemical markers like oxygen, methane, or water vapor in ratios suggestive of life. Elena imagined a future where telescopes could not only detect exoplanets, but map their surfaces, revealing oceans, continents, or even the outlines of alien cities. Adaptive optics, which corrected for distortions caused by Earth's atmosphere or a telescope's movements, would make such imaging possible. Combined with starlight blocking technologies, these advancements could transform our understanding of the cosmos. Chapter 7. The Human Element. Back at Goddard, Elena sat in her office, staring at an artist's rendering of Proxima Centauri b. The image depicted a twilight world, its horizon glowing with a faint light of a red dwarf star. In the distance, shimmering lights dotted the landscape, their source unknown. She wondered what kind of beings might live there. Were they like us, gazing at their own night sky, wondering if they were alone? Or were they so alien that their thoughts and technologies defied comprehension? The discovery had reignited humanity's fascination with extraterrestrial life. Across the globe, people gathered to discuss the news, from crowded cafes to quiet observatories. On X, posts about #Proximalights continue to pour in, some hopeful, others skeptical. "This is our generation's moon landing," one user wrote. "We're on the brink of something huge." For Elena, the discovery was personal. As a child, she spent countless nights stargazing with her father, a physicist who'd filled her head with stories of distant worlds. "The universe is full of possibilities," he told her. Now, as she stood on the cusp of proving him right, she felt a mix of awe and responsibility. The lights on Proxima Centauri b were a beacon, calling humanity to look closer, to push the boundaries of what was possible. Chapter 8. The Road Ahead. The discovery of the lights on Proxima Centauri b was just the beginning. The JWST would continue its observations, gathering more data on the planet's atmosphere and refining our understanding of the mysterious signals. Meanwhile, the scientific community prepared for the next generation of telescopes, instruments that would peer deeper into the cosmos than ever before. The extremely large telescope, with its massive mirror and cutting-edge optics, would complement the JWST's work, offering a closer look at Proxima Centauri b's atmosphere. Future missions, equipped with coronagraphs and star shades, would push the boundaries further, searching for biosignatures on worlds across the galaxy. But the true significance of the discovery lay not in the technology, but in what it meant for humanity. The lights on Proxima Centauri b were a reminder that the universe was vast, mysterious, and full of potential. They were a call to explore, to question, and to dream. As Elena looked up at the night sky, she felt a surge of hope. The stars had always held secrets, but now, for the first time, humanity was beginning to unravel them. The lights from Proxima Centauri b were a spark, igniting a new era of cosmic discovery. Whether they were the glow of an alien civilization or a natural phenomenon yet to be understood, they had brought us closer to answering the question that had haunted us for millennia. Are we alone? Epilogue: A New Dawn. The James Webb Space Telescope had done more than capture light from a distant world. It had captured the imagination of a species, rekindling our sense of wonder and our drive to explore. As scientists continued their work, analyzing data and planning new missions, the world watched with bated breath. The lights on Proxima Centauri B were a mystery, but they were also a promise that the universe held answers waiting to be found. For Elena, the journey was far from over. Each new observation brought fresh questions. Each data set a piece of the cosmic puzzle. She knew that the search for life beyond Earth would take years, perhaps decades. But she was ready. The universe was calling, and humanity was finally ready to answer.